Well, this project has been a long time in development, quite honestly. You could go all the way back to 1988 when we looked at, finished up a master plan talking about how to deal with utilities on this campus. What we ended up doing was knowing that we needed steam. That's what drove this project. We had to have steam, but we could also use the electricity. So we looked at how much electricity we could land on this campus successfully.
We're actually going to use combustion turbine technology, where we use the turbine to spin a generator to make electricity, and we use that waste heat out of the generator to make steam, and then we supplement that with additional gas firing then to make some more steam and send that down the pipe. So really what we're trying to do is for the same amount of fuel going in, we're getting both electricity and steam and getting more efficiency out of the plant.
In order to make this thing cost justified, the bigger you could build that turbine, the better off you were. So we looked at our electrical load and our thermal load on campus, and combined heat and power can only be justified if you balance your thermal with your electric demand.
The technology is it's called an aeroderivative combustion turbine. It's the same turbine technology used on an airplane. It's a very efficient turbine. It uses natural gas as the primary fuel with fuel oil as a backup, but basically it's a jet engine. So you're spinning a jet engine at very high speeds. That shaft is connected to another turbine that ultimately spins a generator. And then the tailpipe, so to speak, of this jet engine, that heat is captured in what's called a heat recovery steam generator. Basically a big heat exchanger that uses that heat to transform the water into steam, and then we send what residual heat and it is left up the stack.
The location we ended up picking was the old main plant right behind me here. We had looked at using the southeast plant or looking at putting a whole new plant up in the northeast, or even looked at putting something in the St. Paul campus, and we'd bring the steam and power over from there. The old main plant provided a outstanding opportunity, provide a stepping stone to future endeavors with regards to utilities on the campus. It's right on the edge of our steam distribution system. It's very capable of getting the power onto campus. So this location worked out perfect for us.
Well, the original building was full of old boilers, old coal-fired boilers, full of asbestos, full of basically all the bad things you don't want in a building.
It's a unique from a combined heat and power standpoint that we're going into an existing facility, and you know, something this old too that's been remodeled numerous times. I believe it's one of a kind in the country for actually going into an old facility.
It's really involved. It takes a lot of thought, a lot of engineering, and it takes really just a good team, both on the engineering design side and construction side, to really make a project like this come together.
The unique thing about it is there's different levels, there's different aspects of it that are, we're hanging pipe that's really high in the ceiling, and we're in tight quarters, lots of people, so a lot of moving parts where people are having to pay attention to what's going on around them all the time.
You know, that's kind of the essence of our job here, is to orchestrate that and make sure everything is getting done on time, in sequence, and just keeping everything meshing and melding, so we get this thing put together and it dances for us.
The turbine itself, just the shell of it weighs 225,000 pounds. And then the Hertzik comes in 8 different pieces, and the heaviest piece on that is 100,000 pounds. And once the turbine's all put together with all the bells and whistles on it, we figure it's going to weigh right around 350,000 pounds. And then that's sitting on a 4-foot thick pad, and then that's sitting on 8 columns, and then sitting on another 4-foot thick pad. So on that bottom pad, we figure there's going to be well over 1 million pounds on that pad.
Some of the concerns have been with getting that turbine from Becker to here, and now getting it from where it's sitting right at the moment down the hill, get the crane hooked up and get it into the building. And I'm confident that everybody's got all their P's and Q's in line. Everybody's to the point where, let's do this. We've checked, double checked, and we've checked again. And it's time that we just move it.
But we've had an outstanding team working on this thing. Everything has been going well. We're working together. We've run into a lot of hurdles, a lot of bumps in the road, but we've managed to work our way through them and get over them, and it's just been a fabulous project. So I'm really looking forward to the day when we're online.
It's a very unique, challenging project, which makes it very interesting. While challenging, it brings some excitement. You know, it's good stuff.